So now that you had a brief introduction from Dr. Mike about what a perfect number is, let's play with it a little bit and see what we can find out. Let's prove that 45 is not a perfect number. It's pretty simple to prove that a number is not perfect. All you need to do is get all the numbers that divide evenly into it, or all of its factors, but they all have to be factors that are smaller than the number itself. The number 45 is a factor of 45, but you can't use that. In order for the number to be perfect, all the factors smaller than 45 that go into 45, if you add them together and they add up to 45, then 45 is perfect. So we're going to show that 45 is not perfect, okay? So here we go. We need to get its factors. Now here's what I want you to think about, okay? If you have a number, like the number 1, it is a factor of 45. Its partner factor, I call it, is 45. It's the number that goes with 1 to multiply together to give you 45. That's a Kellyism. I call these factors partners of each other because they multiply to give you 45. Well, we're not allowed to use 45, so I'm going to cross that off. So 1 and 45 are partner factors, but you can't use 45. Okay, think of another number that goes into 45. Well, I know 5 goes into 45, doesn't it? And it goes 9 times, right? 5 times 9 is 45. Those are partners. You always want to check out the partners to make sure you haven't left somebody out. That's why I always look at the partners. Well, it turns out that the number 3 will also go into 45, okay? And if 3 goes into 45, you will realize that it goes 15 times. So 3 and 15 are partners of each other. Well, are there any other numbers that will go into 45? Well, let's see. Does 6 go in? No. Does 7 go into 45 evenly? No. Does 8 go into 45 evenly? No. So guess what? It looks like we have all the possible factors of 45, right? So now all I have to do is add them up, all right? So if I add 1 plus 3 plus 5 plus 9 plus 15, okay? And I add those together, what do I get? Well, I'll go back here. My adding machine's right here. 1 plus 3 plus 5 plus 9 plus 15, and I get 33. Well, 33 ain't equal to 45, right? Therefore, this number ain't perfect, right? This number is definitely not perfect, okay? Ain't perfect, okay? If you say ain't perfect, I get a kick out of that if you write that on your test. When I give you the test probably this Friday, I will ask you to prove to me that a particular number is not perfect, okay? And this is the process you will have to go through to do that. Why don't we try another one? Let's try 105, okay? So I'm going to put down here 1 and 105. We know those two multiply together to give us 105. Okay, well, will 2 go into 105? No, it won't. So that's not going to help us. I wonder if 3 goes into 105. Well, if you divide 3 into 105, and you divide it by 3, it comes out exactly 35. So 3 and 35 are partners of each other, okay? Well, you know, I think, remember from middle school and high school that a number is divisible by 5 if it ends in 5 or 0, and 105 ends in a 5, so you know 5 will go into it, and you know 5 will go into it 21 times, right? So 5 and 21 are partners of each other. Well, I wonder if there are any other numbers that will go into 105. Well, you see that 21 there. You know 21 is 3 times 7. We know 3 goes into 105. I wonder if 7 goes into 105. So if we take 105 and divide it by 7, we find out it goes 15 times, right? So 7 and 15 are partners of each other. Finally, the partners are going to be so close that we're going to know we've run out of factors, right? So let's see. Will 9 go into 105? I don't believe so. Will 8 go into 105? I do not believe so. So is there any number larger than 7 going up to 15 that will go into 105 evenly? Well, I don't think 8 will. I don't think 9 will. If I take 105 and divide it by 9, whoop, I divided it by 6, I get a decimal number. It doesn't come out even. So 9 doesn't work. 10 won't work. Will 11 work? 105 divided by 11. Nah, it doesn't work either. It gives me a decimal. Will 12 work? 105, excuse me, 105 divided by 11 will not work either. Will 12 work? 105 divided by 12. Now it comes out 8.75. Will 13 go into 105? 105 divided by 13. That's not working either. And 14 is not going to go into it either. So therefore, well, I don't think it is anyway. 105 divided by 14 is 7.5. So no, it doesn't come out even. So those are all the factors of 105. Okay, so what I'm going to do with those factors, all of them that are less than 105, I'm going to add them together. And see what I come up with. Okay, so I'm going to do it back here. 1 plus 3 plus 5 plus 7 plus 15 plus 21 plus 35 gives me a total of 87. 87 is certainly not equal to 105. Therefore, 105 ain't perfect. And if you want to show me an attitude, you can say QED. Quite enough done. I've proved that it is not perfect. Pretty simple procedure, right? So I will be asking you about that on your first test. All right, let's go on. Now, here's a new concept we have not talked about yet. I want you to write 795 as the sum of non-consecutive Fibonacci numbers. Now, what's that mean? Well, look, if you look at the Fibonacci chart, not the Lucas on the bottom, but the Fibonacci's, you see the Fibonacci number 8 here? Next to it is a 13. Next to it is a 21. Those are what I call consecutive Fibonacci numbers. Non-consecutive numbers would be numbers that aren't right next to each other, right? So what we're looking for is to find a sum of numbers that will add up to 795 that are all Fibonacci's. However, none of them are consecutive to each other. Well, how do I do that? Well, you know what? It's not too hard to do. Here's all you have to do. It's very simple. You take 795, okay, and you write it down. And then you say to yourself, oh, by the way, this is found on your sheet called, I believe it is 4B. So if you look on your sheet 4B, okay, let me just double check that real quick over here. All right, yes, it's your sheet called Group Work 4B. Group Work 4B has these problems on it. So what you can do is go to that sheet and you can fill this information in as we go. Sorry, I meant to mention that earlier. At any rate, so I put 795 down. And what I do is I look for the largest Fibonacci number that is smaller than 795. Okay? And that would be, of course, 610, right? So I put down 610. Now, 610 isn't big enough, right? So what am I missing it by? Well, it's 795. And I'm going to subtract from it 610. And I'm left with what? 185. Now, I'm all done with this problem. if 185 is a Fibonacci number. Unfortunately, it is not. So I continue the process now with 185. So I simply write down 795 equals 610 plus, and now I replace 185 with the largest Fibonacci number that is smaller than 185. And of course, that looks like it's 144, right? So I will write 144 here. And now how much short am I from 185? So if I take 144 away from that, okay, I get 41, right? Now I'm all finished if 41 is a Fibonacci number. Unfortunately, it is not, right? So I'm still not finished getting this answer. So I simply write the 610 down again, the 144, which is another Fibonacci number. And now the 41, what is the closest Fibonacci number to 41 that is smaller than it? Well, it looks like it's 34, right? So I replace 41 with 34. I subtract 34 from 41, and I get what? I get 7. Oh, gee, I'm all done if 7's a Fibonacci number because all those numbers added up give me 795, right? But 7, unfortunately, is not a Fibonacci number. It's a Luca number, but it's not a Fibonacci number. I'm looking for Fibonacci's. So I go again, 610 plus 144 plus 34 plus, well, what's the closest Fibonacci that's smaller than 7? It would be 5, wouldn't it? And what's 5 from 7? It is what? 2, right? 2's a Fibonacci number. Guess what? I'm finished. So this is right here the answer I'm looking for. It is a sum of Fibonacci numbers, which when added together, add up to 795 that are non-consecutive. They are not next to each other, okay? So, therefore, I have completed this problem successfully, okay? Now, if you go to the next problem on your sheet called 4B, you'll see I'm asking you to write 795 as the sum of non-consecutive Luca numbers. You do it exactly the same way, all right? So what you do is you start out, you write down your 795, and now we look for the largest Luca number that is smaller than 795. And you can see it looks like on the table down here, it's 521. 843 is larger, so I don't want that. I got to have a smaller one. So now I'm going to do 795. So 795, and I'm going to subtract from that 521, and I get 274, right? Well, I'm all finished if 274 is a Luca number, right? But unfortunately, it is not. So I've got to keep going. 795 equals 521 plus, now what am I going to replace 274 with? Well, the largest Luca number smaller than 274 appears to be what? 199, right? So I write 199, and I subtract 199 from 274 to see what I have left over. And it appears I have 75. Now, you know I'm all finished if 75 is a Luca number. 76 is, as you can see on my list there, but 75 is not. So I got to keep going. So 795 equals 521 plus 199, right? All right, plus, and what am I going to write? 47 here. How much is 47 missing 75 by? So I do 47 minus, and I get 28. Oh my gosh. If it would have been 29, I'd be finished, but I'm not. So I got to keep going. So I go 795 equals 521 plus 199 plus 47 plus what is the closest Luca number to 28 that's smaller? It's 18. And the difference I would get is 10. Unfortunately, 10 is not a Luca number, so I have to keep going. 521 plus 199 plus 47 plus 18, and the closest Luca number to 10 is what? It is 7, right? I'm missing 10 by what? By 3. Hallelujah. I came up with a Luca number. So all of these numbers added together are non-consecutive Luca numbers, which add up to 795. Now, if we look at the table, and I circle these numbers on the table, 521, 199, 47, 18, 7, and 3, you can see none of those numbers are next to each other on the table. Therefore, they are non-consecutive. And if I go back and I look at the problem before, if I circle the 2 in the Fibonacci's, the 5, the 34, the 144, and the 610, you can see that none of those are consecutive Fibonacci numbers, okay? So that's the process you have to use to determine the answer to finding out these non-consecutive additions that work out. So I'm asking you to try a Fibonacci number for me tonight to write it as a sum of non-consecutive Fibonacci's. So that will be on the sheet called Group Work 4, which remember is what? It is part of Group Work 4B's PDF file. So you'll be able to print that and do it and then take a picture of it and send it to me to show me you've done it. All right, now we're going to get a little bit into the future of what I'm going to be doing in our next class. Discovering still more Fibonacci relationships by experimenting with various examples in search of a pattern. Determine a formula for f sub n plus 1 times f sub n minus 1 minus f sub n squared. That is a formula for the product of a Fibonacci number and the Fibonacci number that comes after the next one minus the square of the Fibonacci number between them. And the answer will be different depending on whether n is even or odd. Consider examples of the different cases separately for 4, 5, 6, 7, and 8. Wow, that's a lot of work. Well, here's how you do it, okay? Here's how you do it. Now, I rewrote the formula that they're asking us to evaluate in a little bit different notation. I didn't put a time sign between the first two terms here. Okay, so I'm going to take f sub n minus 1, I'm going to take f sub n plus 1, and f sub n and square it, subtract that square away, and see what I get. And I'm going to see if I can find a pattern. Now, it said, when we go back to the problem, to do it for 4, 5, 6, 7, and 8 values of n. So the value of n we're going to start with is when n equals 4. So let's see. I'll do it out very simply first, and I'll take some shortcuts later. If I write the n as 4 here, this is going to say f sub 4 minus 1, that multiplied by f sub 4 plus 1 minus f sub n, well, n is 4. We're going to square that. What are we going to get? Well, this is really f sub what? 3, right? This is really f sub 5, isn't it? 4 plus 1 is 5 in the subscript. And this is f sub 4 I'm going to square. Now I'm going to go get those Fibonacci numbers now. F3, to make sure you read the Fibonacci's, not the Lucas. The Fibonacci number F3, the third one, is the number 2, right? The fifth Fibonacci number, it happens to actually just be 5, all right? And the fourth Fibonacci number happens to be a 3, if you look on the table. So now if I evaluate this, I get 10 minus 9, or an answer of 1. How about that? So when n was 4, I got the answer 1. Well, what if I tried over here for n equal to 5? So what I do, now I'm going to take a bit of a shortcut here. What is f sub n minus 1 if n is 5? Isn't it f4, right? What is f sub n plus 1 if n is 5? If I put 5 in for n, I get f sub what? 6. And I'm going to subtract from that. The value of n for f sub n is f5, and I'm going to square it. Well, let's see. I go to my table. Fibonacci number 4 is a 3. Fibonacci number 6 is an 8. And Fibonacci, the fifth Fibonacci number is actually 5, which I have to square and then subtract here. So let's see, it's 24 minus 25. Well, what is 24 minus 25? It's negative 1, right? So the first time I got a 1, the second time I got a negative 1, right? All right, let's go on. Let's go to, you've got more room on your sheet. I have to bring up another one. Let's go to n equals 6. Now, if n is equal to 6, remember, the first one will be Fibonacci number 5 multiplied by Fibonacci number what? 7, right? Because I put a 5 in for n minus 1, it becomes, I'm sorry, I put a 6 in for n minus 1, it becomes a 5. I put a 6 in for f sub n plus 1, it becomes a 7. And of course, f sub n will just be f6. And I'm going to square it. I go to my table. F sub 5 is 5. F sub 7 is what? 13. And f sub 6, looking at the table, is an 8. And I'm going to square the 8. So I do 5 times 13, that's 65, minus 8 squared, which is 64. I get 1. Well, let's try another one. Let's do n equal to 7. Okay? Now, if n is equal to 7, see if you can fill this in as I go here. What should the first one be? If you put f6, you did it right. And for the next one, next part, if you put f sub 8, you did it right. And we're going to subtract from it what Fibonacci number? F sub 7. But we have to square it. Well, I go to the table. F6 is an 8. F8 is a 21, right? And I'm going to square f sub 7, and that's 13. Well, 13 squared, I believe, is 169, right? And 8 times 21 is 168. Notice I get negative 1. Let's go back here to the last thing where we started it. We got 1 if n was 4. If n was 5, we got negative 1. For n was 6, we got 1. For n was 7, we got negative 1. So what do you think the rule is here? What do you think is the pattern? Well, if the value of n is even, right? If the value of n is even, we're going to get a positive 1 for the answer. If f sub n is an odd number, we're going to get a negative 1. Interesting, huh? Now, how can I write that as a general formula using the f sub n notation? Well, what it would say is this. I'm going to scribble out the question mark here, and I'm going to say I'm either going to get positive or negative 1, right? So how can I write that? plus or minus 1. Each time I'm going to get, you remember that symbol from high school? Plus or minus 1 is going to be the answer every time to this particular problem. Now, when we get together for class next time, we are going to look at some more complicated situations of these kinds of formulas to try to locate or understand the pattern that they show, okay? So I just want you to see one today so that you could get an idea of what's going on here, okay? All right? So, with that being said, all right, let me go here. So now I'm up to where it says group work 4, which is your homework. All right, so I'm going to stop here now, and I'm going to ask you to do these problems, okay, on group work 4, which is the second 2 pages on the PDF of group work 4B, all right? So if you can print those, if you can't print them, then just look at them on the screen on your computer, or when you download the PDF, just look at them on your screen and do the work on a separate sheet of paper, and just take a picture of it and send the pictures to me. And remember, you send them to my cell phone, which is the 866 number, okay? So this concludes our work for today, okay? And I appreciate your patience. There was a lot of videos to look at. But you notice I haven't been giving you any videos to watch at home. So we're basically well, you're watching them all at home, but I mean, no videos to watch before the next class, at least at this point. So all I'm going to ask you to do is 4 problems on group work 4, okay? So take your time, do a good job, and hopefully you will understand them. So I'm going to bid you adieu today to finish the class, and I will see you on Wednesday. So hope all goes well, and we'll talk soon, okay?